Hi everyone, welcome to geometry. We are in the last lesson of Unit 1. So up to this point, you should have completed 4 geometry lessons, and today is day 5. Remember that on Mondays, you have an asynchronous lesson in Play Pause It. I used to teach live on Mondays and Wednesdays, but now Monday's time is used for teaching small group and my honors section. So I can't be in 2 places at once. And because of that, your Monday lesson is in Play Pause It. You still have to do it. There's still an attendance quiz for it. There's still an exit ticket for it. And all that material is fair game on a test. So please make sure that you've completed the Play Pause It's. Those of you that have done it, I thank you very much. And if you haven't done it and you have no idea what I'm talking about, you might want to send me an email so that I could help you find it and make sure that you are caught up. Now also know that because this is the last lesson in the unit, that means there's going to be a test, right? So there's a unit review available for you, and there's also the test open. I want to show you where to find the review because I think it can be very, very useful. I'm going to share my screen with you real quick. Okay, when you log into our class, click on content, of course, and then you're going to go, of course, to Unit 1, since that's the review we're looking for. When you're in Unit 1, right before the unit assessment is a folder called Unit Review. In that folder is a PDF of a review for you, and then there's a video of me doing the review. So maybe you print out the review, you try it on your own, and then you watch the video and check your answers and get help with any of the problems that maybe you were stuck on. If you can do the review, the test will feel easy. You only get 1 attempt on the test. And once you open that test, you have to complete it in 1 sitting within 3 hours, just like it says on the syllabus. So as soon as you click on that test, you have 3 hours to complete it, and it will close after 3 hours. So if you open it prematurely, I'm really sorry, but it will close in 3 hours, and there's not really anything I can do. Don't start it until you're ready for it. Okay? Don't tell me you're going to fail it. That's not positive thinking. Do the review. Have faith in me. Do the review. If you are on the review and there are problems you have no idea how to do, that's when you come to office hours and we'll talk about it and I'll help you out. Okay? Don't start that test until you're ready for it. With the exception that, of course, it has to be done before the end of the quarter, which is October 15th. Okay? The test will close in 3 hours. Yes, the test. So once you click on the unit assessment and you open that test, the clock starts ticking. It's not a long test. 3 hours is way more time than you will need. I promise. 3 hours is a ridiculous amount of time that you're going to need on that test. I mean, some people will probably be done in 15 minutes. Some people might take an hour. If you take all 3 hours, that's fine too. But the 3 hours is a very long time for the test. You would find the test in the unit assessment folder. Okay. And it's open right now, but once you open it, it's over. I don't remember how many questions are on the test, to be honest with you, but it's like 30 or less, I'm sure. It's not long. Okay. Where are we? Here we go. Okay, so we are doing lesson 5 today. And after this, that's the end of the lessons for Unit 1. There's a 1-2 quiz that you'll need to complete, and then the test when you're ready for it. And again, if you do the review and you're stuck and you need help, please come visit me during office hours or send me an email and I'll help you out. Let me help you. It's okay. All right. Now I'm going to turn my camera off. I have this horrible cough. And if I mute myself for a minute, just give me a second. I'll be back. I just keep coughing and I don't want to cough in your ears. So, here we go. All right. So on your screen, you see 5 different angle relationships. These are angle relationships that I'm told you have learned before in the past. If you haven't learned them in the past, that's okay. I'm here to teach you right now. If you have learned them in the past, hopefully this feels like a review. Okay, I'm going to start with vertical angles. Vertical angles are two angles that are across from each other on intersecting lines. So you're going to have two lines that intersect each other, and the angles that are across from each other are called vertical. Okay, so I'll call that angle A and angle B. Vertical angles are always congruent, so I can say that A equals B. Oh, it's an equal sign. There we go. Okay. Adjacent angles are two angles that are next to each other and they share a common side. So I've got like a big angle here, and it's made up of two angles. Okay. Here they are. They have a common side, and they're right next to each other. Those are called adjacent. Complementary means they add up to 90. So you'll have a picture of a 90-degree angle. It will either have to tell you it's a 90-degree angle, or it'll give you this little box, which means 90. And it will be made up of two angles. We'll call those angle A and angle B. The angle A and angle B are called complementary because their sum, or when I add them, is 90. Okay, supplementary means that I've got two angles whose sum is 180. Maybe the picture would look like this, where you have two angles, right, and their sum is 180. But they don't have to be adjacent, just as long as their sum is 180. So I could have, oh, my screen's being silly. There we go. I could also have like an angle over here and an angle over here, and even though they aren't touching, as long as they add up to 180, they're called supplementary. Okay, so two angles that sum to 180, that is supplementary. A linear pair are two angles that are adjacent and supplementary. They form a straight line. So I have a line, two angles forming that line. They're adjacent because they're sharing a side, and they are supplementary because they add up to 180. So a linear pair, okay, see the word line, right? Pair means two. So a linear pair are two angles that form a line. I hope this felt like review to you. On your screen, you're going to see a poll. If this felt like review, you already knew these words, give me a smiley face. If you remember hearing them before, but maybe you don't remember exactly what they meant, give me a middle face. And if you have never heard these words before, this is completely foreign to you, give me a frowny face. This is a really good way for me to see how you're doing on this and who just walked away from their computer after they logged in. Fatima, I'll check my email when I'm done teaching. I teach until 2 o'clock today. All right, this is very promising for me, guys. Yay. All right, so for the most part, we're feeling good on it. I'm glad. If you were one of the people who gave me a frowny face, maybe put a little star next to this and know that we just need to practice these relationships a little bit, and that's okay. Okay, so let's practice them here a little bit. In the picture, you have an angle 1 and angle 2. I want to know what kind of relationship are we looking at? And it could have more than one. It can be adjacent and supplementary at the same time. And if it is, then that's a linear pair, actually. But let's look at number 1 here. I got angle 1 and angle 2. Angle 1's over here. And angle 2 is down here. They are formed by two lines that are intersecting. Now, they aren't sharing a side, so they cannot be adjacent. I don't know their measures. And so since I don't know their measures, I don't know if they add up to 90. So I can't say they're complementary. I can't say they're supplementary because, again, I don't know their measures, and they aren't even making a line. And since they aren't making a line, they're definitely not a linear pair. So the only relationship that angle 1 and angle 2 have in this picture is they're vertical. Yay. Thank you, Christian. right, let's get number 2. I got angle 1 and angle 2. Here's angle 1, here's angle 2. Well, I see this little box right here. See, that means 90 degrees. Okay. Well, if I have a line and I know this piece is 90, it means this piece over here also has to be 90 because 90 plus 90 equals 180. Okay, well now angle 1 and angle 2 are making that 90-degree angle. They're sharing a side, so they're definitely adjacent. But they aren't across from each other on any intersecting line, so they're not vertical. Together, they're making a 90-degree angle, so they're complementary. They're not supplementary. They make 90, not 180. And they're not forming a line. They're complementary, so they're not a linear pair. So here I would choose adjacent and complementary. Let's look at number 3. I have angle 1 and angle 2 here. Angle 1 is here, and angle 2 is down here. Okay. I'm going to ignore this part of the picture up here. Pretend that it's not even there. Okay, so I've got this line with angle 1 and angle 2. They're sharing a side, so they are adjacent. Now they're not across from each other, right? Because across from 2 would be up here and across from 1 would be over here on the right, so they're not vertical. They're not making a 90-degree angle, so they're not complementary. They are forming a line, and a line measures 180, so we are supplementary. And they're forming a line. They're adjacent, they're supplementary, so they're a linear pair. All right, I'm going to let you do number 1. Now, I'll tell you there's just one answer. Number 4. I'm going to let you do number 4. There's just one answer for number 4. What do you think? Are they adjacent, vertical, complementary, supplementary, or a linear pair? So if you think they're adjacent, you're going to click a 1, vertical 2, complementary 3, supplementary 4, linear pair 5. What do you think? All right, if you think they're adjacent, click the 1, 2, vertical, 3, complementary, 4, supplementary, 5, linear pair. What do you think? All right. All right, if you said 1, you are correct. Okay, now some of you, I think it tricked you, right? It kind of looks complementary. I agree, it kind of does. But because there's no 90-degree angle there, you can't assume that it's 90 degrees. Maybe it's 93 degrees. You don't know. So never assume it's a 90 degrees unless it tells you. Like if there's a box there, like there was up here in number 1, perfect. That's 90 degrees. But if that box isn't there and the directions don't say anything about being 90 degrees, please don't assume it's 90 degrees. So since we don't know it's 90, complementary is not an option. They're not making a line. Right? This is clearly not a straight line. So it's not supplementary or a linear pair. Vertical angles have to be across from each other, like up here in number 1. So they're not vertical. So if you said adjacent, you were correct. If you didn't say adjacent, you said something else, put a little star here because these are relationships that you should definitely study. I'm going to leave number 5 and number 6 there for you to practice on your own because we need to move on to the next one. We need to practice actually solving when we have angle relationships. Looking at number 1, I see adjacent angles. Not adjacent, sorry, vertical angles. I can talk. Vertical angles. They're across from each other. Right? Here's on top and on the bottom here. They're formed by intersecting lines. And looking at the first slide, we see that vertical angles are always congruent. So if that top angle is 112 degrees, so is the bottom. All right, looking at number 2, I see that box. That box means 90. That's good. Okay, well, that means these two angles are complementary. Two angles making a 90-degree angle. You kind of were doing this when we did angle addition. I just didn't use the word complementary. Well, these two angles together have to make 90. The sum of the two angles is 90. So just subtract 68 from both sides. 22 is our answer. Yay, thank you, John. You're right. All right, and now let's look at number 3. I have two angles that are forming a line. These are adjacent. These are supplementary. So this is what I would call a linear pair. A pair of angles, two angles that form a line. So I'm going to say 124 plus x equals 180. And if you just skip this step and you just immediately do 180 minus 124, great. That's fine. I don't mind. 56. All right. Now let's see here. What happens if there's more than one variable in the picture? Well, you can just take it one step at a time. All right. If it's not already there for me, I like to put like an x equals, y equals, z equals, just so I don't forget to do one of them. And I personally like to look at vertical angles first. Maybe you like linear pairs first. That's fine too. I like vertical angles first just to see what's equal, right? Well, I know that 43 is vertical to y because they're across from each other on my intersecting lines. So y has to be 43. Now what I'm going to do is I'm going to look at my lines. So let's see here. Here's a line. Okay. And together, this angle and this angle has to be 180 because that's what a line measures. Well, that looks ridiculous. Okay, they're a linear pair. So x and that 43 together has to make the line, or the 180. So when you subtract 43 from both sides, you get 137. Solving for z, you could do another linear pair, or you could recognize that the x and the z are vertical. So those have to be the same. So if x is 137, well, so is z. All right, let's look at number 5. All right, let's see. I know this is 90 degrees right here. That's what that box means. Okay, that's good to know. Let's see. I'm going to look for some vertical angles. Here's two lines that intersect each other. So that means these two angles have to be the same. So y has to be 72. Okay, now this got really messy, but let's see here. Let's look at x. Here's a line. A line has to be 180 degrees. So x and that 72, that whole thing, together has to be 180. So I can say x plus 72 equals 180. Or just subtract 72 from 180. So x is 108. Hey guys, be really careful with the 108s. We use 180 in this class so much that when the answer is 108, and I'm guilty of this too, we type it in wrong just because we're so used to typing in 180 or writing 180. When our answer becomes a 108, sometimes we mistype it. So if you ever get an answer that's like 108, just triple check and make sure you typed it in correctly into the computer. All right, let's do z. All right, I've got a huge mess here. Let me erase all of the stuff I have here. Okay, so far, we know that this is 72. We know this is 108. Of course, this is 72. Let's find z. Remember, this is 90, right? So here's a line, which means this over here also has to be 90. So z and 72 together have to add up to 90. So subtract 72 from both sides, you get 18. Any questions on how I found X, Y, or Z here for number 5? Which was missing? They were all missing. We had to solve for X, Y, and Z. We didn't know any of them. All right, let's see here. Number 6. If you don't have a picture, then you need to draw one. And of course, you don't have to be a great artist or anything. I certainly am not. And you'll see that as the year goes on. But you can draw a picture of vertical angles. Remember, vertical angles are 2 angles formed by intersecting lines, and they're across from each other. So we'll call this angle 1 and angle 2. We could have put them on the top and bottom. It didn't matter. If the measure of angle 2 is 105 degrees, then what's the measure of angle 1? Well, vertical angles are congruent. So the measure of angle 1 has to be, you're right, Andrew. Anyone else? Anyone else want to chime in? What do you think measure of angle 1 is going to be? Yay. Yay. Awesome. Good. A waterfall of 105s. You're right. Okay, that might not have been so easy if you didn't draw a picture. Okay? Don't resist the drawing a picture. Grab a whiteboard. Grab a scrap piece of paper. Draw a picture of 2 lines. Put 1 and 2 in there, and it makes the problem so much easier. So in number 7, our keyword here is complementary. Complementary means they sum to 90. So I better see a 90-degree angle in your picture. And there's 2 angles that make up that 90-degree angle, angle A and angle B. What does the line with the angle symbol mean? Camilla, do you mean this thing right here? Yeah, so the question is, why does this angle symbol have a line through it? The reason is mostly my handwriting is really sloppy. Well, on the computer it is anyway. When you type it, an angle symbol, it looks all nice and pretty, right? Like this looks beautiful. Eventually, we're going to be working with less than and greater than symbols, and I don't want my angle symbol to be confused with a less than symbol. So I put the little arc through my angle symbol when I'm writing it by hand. Yeah. If you aren't going to confuse it with a less than symbol, you don't have to put the arc through it. I just do, so that way it doesn't look like a less than. That was a really good question. Right, back to number 7 here. We've got a picture of 90 degrees. A and B are splitting that 90 degrees apart into 2 parts. The measure of angle A is 42. Find the measure of angle B. Well, we know together they have to make 90. So 42 plus whatever B is has to be 90. Subtract 42 from both sides, and Deacon, you are correct. It is 48 degrees. Yay, if you type 48 degrees in there, you're right. It's really an angle. So the measure of angle B is 48 degrees. All right. Let's look here. All right, I'm going to let number 8 and 9 be for you to practice on your own. However, I do want to give you the attendance word. Today's attendance word is supplementary. Here it is. Supplementary. Yeah, it's a big word. You got to spell it right too. Write that down. Or highlight it in your notes. Or go do the attendance quiz in a separate tab and do it right now. I don't care. Supplementary. Supplementary. Once you've written it down, click the checkbox. Uh-oh, Ethan. Ethan, leave the class and come back in. I'll watch for you and let you in. Clear your cache and cookies. That might help too. All right, Ethan, I hope you can see them now. All right, write down supplementary because we are going to move on. Gotta spell it right. If you spell it wrong, I cannot reopen it for you. And look at all the people not paying attention right now. That's interesting. I try to make them so you can't guess them, Fatima. I'll have to start making them harder. Capitalization doesn't matter. Nope. You can do it capitalized, lowercase. Yep. All right, moving on. You're going to do number 8 and 9 on your own. You can check the key. If you get them completely wrong and you don't know why, send me an email with a picture of your work and I'll help you out. You can also check the key. It's posted on OMHS for you. Let's look at number 10. Let's do some more algebra. I love doing the algebra with this stuff. Just like any problem, just go one step at a time. A lot of times in geometry, if you have to draw a picture, then draw it. But take what's given to you and put it in the picture. Once it's in the picture, it makes the setup a million times easier. Maybe not a million, but you get the idea. So find P, find Q, find T. There's angle PQT. Put 3x plus 47. Oh, geometry involves a lot of algebra. That's why algebra is a prerequisite for it. Yeah, unfortunately. But if you need help with the algebra, that's what I'm here for. I'm here to help you. The measure of angle SQR, so find S, find Q, find R, that's 6x minus 25. Oh, look, as soon as you put those in the picture, I'm hoping that you can recognize the angle relationship that they have. These guys are vertical angles. Vertical angles are equal or congruent. So you say 3x plus 47, and that 6x minus 25, they have to be equal. Oh, good. I'm glad you got it, Ethan. Awesome. So maybe you were way ahead of me. Okay, let me keep going. You're like, keep going, Miss Grandy. You're too slow. Okay. I'm going to subtract 3x from both sides. Let's add a 25 to both sides. 72. And if you need to show more work than this, like if you need to like put the little plus 25, that's fine. I'm okay with that. If you use Desmos to solve it, great too. I don't mind. However, you get 24. Now, if you type 24 into the answer, you're going to get it marked wrong because it wants to know what's the measure angle SQR. So what you got to do is go back up to your picture. SQR, that's 6x minus 25. 6 times 24 minus 25. Push some buttons on your calculator. You should get 119 degrees. Okay, we always measure an angle in degrees. Now, please be very careful. On a quiz, I have tried to make the quizzes as easy for you to type in as possible, and some people are trying to be way too fancy. If this was an exit ticket question, it would look like this. Measure of angle SQR equals box, and it has the degree symbol for you already. Just type the number. If you put the degree symbol in the box, the computer's going to mark it wrong. Okay, so I've tried to make every single question so that you can use only the keys on your keyboard to answer. Okay, so if you are finding yourself using symbols that you wouldn't find on a regular keyboard, then you're probably just trying to be too fancy. Okay. And if you're not sure, or if you are certain you put it in right, but you think the computer's marking a symbol you put in there wrong, just send me an email and I'll look at it for you. Okay. All right, Fatima, I would love to help you, but not in the middle of class with that right now. Okay. You can send me an email. Let's look at number 11. Wonderful. Awesome. I will look at it then. All right, number 11. If line AB is perpendicular to ray CD, remember perpendicular is this little symbol. It looks like an upside down T. It means that they intersect each other at 90-degree angles. So I find AB. Here's AB. I find CD. There it is. They are perpendicular, which means this is a 90-degree angle. Okay, so I'm just going to put that little box in the picture because I know that's what perpendicular means. Now, the measure of angle DCE, so I find D, I find C, I find E. I'm going to label that 7x plus 2. ECB, I find E, I find C, I find B, x plus 8. And then it says find the measure of angle DCE. So we're going to solve for x, and then I'll be able to use that x to plug in and actually solve for DCE. Some people on some exit tickets, even the quiz, if it asks you to find the measure of something, I'm expecting you to type in a number, 42, 37, 19, whatever. If you find yourself entering an expression, that's going to be marked wrong. I'm not asking for an expression that represents that angle. I'm actually asking for the number. So you're going to have to solve for x and plug it in. Okay, so if you find yourself entering an expression into the measure, then go back and redo that one. Okay, make sure that you're actually answering, like finding the measure and not just an expression. All right. So let's see. If this angle over here is 90, right? If this is 90, that means angle DCB has to be 90 also, because I'm looking at a line. A line measures 180. So if half of this is 90, the other half has to be 90 also. So this is also 90 degrees. And so here's 90. So I've got some complementary angles. I have 7x plus 2 plus x plus 8 equals 90. If you didn't recognize that, but you know that a line is 180, right? Then you could have said, oh, well, this 90 plus 7x plus 2 plus x plus 8 equals 180. That would have been okay. We're going to get the same value for x. So if you would rather do it that way, where you actually add the 90 in and then set the whole thing equal to 180, I'm okay with that. Personally, I think what's in blue over here is a little easier. Just less things to combine. Okay, don't forget to combine your like terms. 7x and 1x is 8x. 2 plus 8 is 10. Subtract 10 from both sides. Divide by 8. Wonderful. If you entered 10 in the box, it would be marked incorrect because we're looking for the measure of an angle. So you got to go to the measure of angle DCE. Well, DCE is 7x plus 2. So you would type 72 into the box. 72 degrees is the measure of our angle. Any questions on what I did there? If you have a question, you're welcome to type it in the chat. I'm happy to answer it. I'd like you to try number 12. Okay. If you have a scrap piece of paper right there, go ahead and draw the picture. If you have the notes printed, perfect. You can do it right there. Wipe off board, whatever. Put the given information in the picture and then write an equation based on the relationship that you see. Then you're going to solve for x, and I want to know what is the measure of angle KNM. Try that now. I'll give you 3 or 4 minutes. Go ahead and try it. Okay, so I have put how I set up the equation on the board. Make sure that you are labeling your angles carefully. K and M is 8x minus 5, so make sure you have your 8x minus 5 in the right spot. M and J is 4x minus 19. These are not across from each other. They are not vertical. So if you made them equal, then that is where your mistake happened. Okay? They are not vertical, so they are not equal. Here's another way to tell. This angle right here, let's make that fatter. This angle right here, that's an obtuse angle. Clearly it's obtuse. This angle, that's acute. There's nowhere in this world that you're going to find an acute angle and an obtuse angle being the same, because acute means less than 90 and obtuse is bigger than 90. There is no number that is bigger than 90 and less than 90 at the same time. Okay, so if you're telling me that an acute angle equals an obtuse angle, you're going to get that wrong every time. So even if you didn't recognize maybe the word vertical, but you at least recognized, they're not. Well, they aren't vertical. But if you didn't recognize linear pair, you at least recognize that they weren't equal. So these have to add up to 180. So then you combine your like terms. Whoa. Add 24 to both sides. Divide by 12. Okay. If you told me 17, then you solved for x wonderfully. Make sure you answer the question though. The measure of angle K and M is, let's see, K and M is 8 times 17 minus 5. That's 131 degrees. If you typed 131 degrees in the box, I tried to respond to you. I think I got everyone. If you didn't get 131, check your work. Did you set it up right? Maybe you just added or subtracted wrong somewhere. How did we do? Okay. All right. If you found your mistake, I'd give yourself like the middle smiley face. If you got it right, give yourself a green smiley face. If you have no idea what's going on, click the frowny face. Okay. If you find yourself clicking a frowny face right now, please put on your agenda to come see me during office hours or to email me and tell me exactly what you want help with, because I am here to help you. Okay. So this frowny face is step 1 to getting help. Step 2 is emailing me or coming to office hours or both. All right. Number 13. It looks very much like number 12, doesn't it? Now, there's a little bit of difference here. It says find the values of x and y. We've got 2 variables, but we can do it. Put the given information in your picture. So DEG is 5x minus 4. So that's over here. GEF is 7x minus 8. And DEH is 9y plus 5. All right, we don't want to deal with a system of equations. That's an Algebra 2 standard for sure. So let's do it a smart way. What you want to do is you want to write an equation that only has x's in it or that only has y's in it. If you find yourself writing an equation that has an x and a y in it, you're setting yourself up for a much more challenging algebra problem than you could be. Okay, so I see 2 expressions with x's and 1 expression with y. We're going to pretend that that y is not there. Okay, we're going to actually just ignore this whole bottom part. Pretend this doesn't even, it's not there. Goodbye. All right, I'm only going to look at that piece for right now. What kind of angle relationship do you see? Do you see vertical angles, or do you see a linear pair? You can type it in the chat. Vertical or linear? I see lots of good stuff. Yay, yay, yay. Good. This is a linear pair. Very good. Okay, so they're a linear pair. Linear pair is supplementary. Ooh, this is a really good question. Is supplementary and linear pair the same thing? Not really. Kind of. So supplementary just means they add to 180. The angles don't have to be touching each other if they're supplementary. I could have one angle over here on the left and one angle over here on the right, not touching each other at all. And as long as they add to 180, they're supplementary. But a linear pair, those two angles have to be like adjacent to each other or sharing a side. A linear pair is supplementary, but not all supplementary angles are linear pairs. Yeah, that was a really good question. Okay, so we say they're supplementary. So we add them together to get 180. All right, combine our like terms. Oh, 12x. Oh my goodness, let me try that again. Add 12 to both sides. Divide by 12. We'll get 16. All right, so x equals 16. Lovely. Now I need to solve for y. Okay, so now I'm going to go back and be like, oh yeah, the rest of the picture actually does exist. What was this? 9y plus 5. Yeah, Dylan, you're right. Oops. Okay, so now that I know that x equals 16, I'm going to go back up here and I'm actually going to plug in that 16. 7 times 16 minus 8. What do we get? 104. So this angle will also have to be 104 because we have vertical angles now. They're across from each other. So we can say that 104 and that 9y plus 5 have to be the same. Subtract 5 from both sides. Divide by 9. If you found it a different way, maybe you plugged in the 16 over here and then you found the linear pair down here. That's fine too. You're going to get the same answer. Okay, so if you have a picture that has two different variables, pick one variable to start with, and I usually pick the one that I have two of. So like I had a 5x minus 4 and a 7x minus 8. I wanted to deal with those first. Solve for the one variable, plug that in, and then worry about the second variable. How did I get 104? I plugged the 16 into the 7x minus 8. 7 times 16 minus 8 is 104. So my picture got kind of messy, but if I were to redraw it, I would have a 104 up here and the 9y plus 5 down here. Okay, I want to make sure that we cover everything here. I am going to leave numbers 14 and 15 here for you to practice. The answers are on the answer key, so you can check your work. And if you get stuck, you know you can ask me for help. But I want to make sure we cover all of the notes. Just know that, you know, keywords here. Complementary. So if you seek the word complementary, your setup should be something plus something equals 90, right? Supplementary. Your setup, you're going to have something plus something equals 180. And then you'll solve and answer the question. All right, so those I'm gonna let you do numbers 14 and 15 on your own, and then we're gonna skip ahead here to the next one. And it says if ray UW bisects angle TUV. Ethan, it's gotta be your computer. I'll watch for you again. I'll watch for you and let you in. All right, so bisect means two equal parts. So TUV being cut into two equal parts. So those two angles have to be the same. The measure of TUW is 13x minus 5. So I find T, I find U, I find W. That's 13x minus 5. And the measure of WUV is 7x plus 31. Find the value of x. Okay, well, if these two angles are the same, that means these two expressions are equal. Man, that felt too easy. All we have to do now is solve for x. Subtract 7 on both sides. 7x. Add 5 to both sides. Divide by 6. Ethan, do you see the screen now? All right, so bisect, of course, means two equal parts. We need to be able to do this, know that, to be able to solve the next problem. So that was just a little review of bisect. Hopefully changing the screen there helped, Ethan. All right, so MO bisects angle PMN. MO is here, and it's bisecting PMN. Bisect means two equal parts. There we go. The measure of angle PMN, so that's the whole angle there, is 74. OMN is 2x plus 7. Okay, so it's so little, I'm going to use this little arrow here. That's 2x plus 7. That's this guy right here. Ethan, take a screenshot of what you see and email it to me, and I'll try to help you out that way. Okay, so now there's two ways to do this. I'm going to show you both ways, and you can decide which way you like best. I don't think either one's really better than the other. But if I know that the whole angle is 74 and I cut it in half, well, then 74 divided by 2 is going to tell me what each piece equals. So what's 37? So I know that each of these little dudes is 37. So I can say that 2x plus 7 equals 37. The other option is to say, oh, well, I know angle addition. And if this little piece is 2x plus 7, then this little piece is also 2x plus 7. So 2 of those has to equal the big guy, 74. Either way, you're going to be able to solve for x. I like over here in green. It's just a lot faster, I feel, to solve. But if you solve what was in red, you're still going to get 15. Okay, one more. Yay. The last one in the notes here, number 20, says if EF bisects angle CEB. So we're going to find EF in the picture. Here it is. Angle CEB is here. Okay. Angle CEB is being cut into two equal parts. So this angle equals this one. Okay, I'm going to get rid of all this mess, but we know this angle equals this angle. Now it says the measure of angle CEF is 7x plus 21. And FEB is 10x minus 3. We're going to find the measure of angle DEB. DEB. That's this guy. Well, let's start by solving for x. We know that these two angles are congruent, which means that their expressions are equal. So we can solve for x. Subtract 7x from both sides. Add a 3 to both sides. Divide by 3. Okay, well, now I can take that 8 and I could substitute it in here. 7 times x plus 21, that's 77. 10 times x minus 3, that's still 77. Right, because 7 times 8 plus 21, 10 times 8 minus 3. So just so you can see what I'm doing here, okay, You don't have to erase what's on your paper. I just want to make it clear what I'm doing here. Okay, we just determined that this angle was 77 and this angle was 77. And we know that this is a line. Well, we know that the measure of a line is 180. So we could say 77 plus 77 plus the angle we're trying to solve for equals 180. So we can solve for that question mark. Combine our like terms. You can use question mark as your variable if you want. Subtract 54 from both sides, or 154 from both sides. Okay, 26. So the measure of the angle we're looking for, DEB, that's 26 degrees. Yay, good job, Deacon. Ethan, just send me some kind of email so that I know to look into it for you. Kind of puts it on my to-do list. It's okay if you don't have the screenshot. Okay, so that is the end of Unit 1. How about that? What looks like a weird clock? Is this a joke? Oh. My handwriting? All right, so don't forget to do the exit ticket. Don't forget to do your attendance quiz. The attendance quiz closes at 11 a.m. 1 week from today. So make sure that you do that. Make sure that you've done the play posits on Mondays because those lessons are fair game on the test. So once the exit ticket, I can't really like tell you how to do until you've actually done it. Otherwise, that just kind of ruins the integrity of it. But if you need help with any of the questions on the practice, which looks very much like the exit ticket, you're welcome to ask me any of the questions on the practice or a similar question during office hours, or even in an email. I can do that for you too. If you had been bumped out of class and you had to come back in, you might want to just rewatch the recording to see what you missed when you had been bumped out. But other than that, that's all I have for you. Don't forget to do the review and start the test when you're ready. Yes, Fatima, I will check my email. I promise. Cross my heart, I will.